Hello, for today we are going to explain the concept of solution of triangles and how to solve problems using different types of triangle or involving different types of triangle. First of all, we are going to look at the right-angled triangle. For the right-angled triangle, if we want to get, remember this is the general introduction about everything that has to do with triangles. After we are going to take specific examples to illustrate further. If you have a right-angled triangle and we want to, the triangle is a shape with three sides, three angles, so we can only be asked to determine the length of one of the sides or the angles involved. If you are given two angles, of course, the sum of angles in the triangle is 180 degrees. So if you are given two angles, you can always get the third one by subtracting 180. Subtracting the other two from 180. Now the question is, what if we are given only one side? Let's say 40 degrees, or let's take 30 degrees, and you are asked to find the length of the sides. Remember, the length of the sides can easily be figured out if we are given like 5 and 4. We can use Python. With Python, we can say that 5 squared, because it is a hypotenuse. Remember, Python says the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. So we can use 5 squared is equals to 4 squared. And that can help us to get the unknown length. So here we can easily figure out that our unknown length will be 3. In this case, the length of two sides was given in a right-angled triangle. And we are required to get the third one because it is only a right angle. Now the question is, what if we are given angles but only the length of one side for this, for instance this, and we are asked to find the length of the other? We don't have two sides, so we cannot use our Pythagoras theorem. So what do? We apply the second approach, which is SOHCAHTOA. SOHCAHTOA means that when we are dealing with the opposite and the hypotenuse, we use sine. Now, how do we figure out our opposite and hypotenuse or adjacent in a given triangle? Now we are given 30 degrees. If we are given 30 degrees, it means that the angle facing the 30 degrees, for that case, will be our opposite. Our hypotenuse never changes. For every right-angled triangle, the hypotenuse will always be the length of side facing the 90-degree angle. Then, and the other one will become our adjacent. If we were solving using this angle A, then BC as a length will be our opposite, whereas the other side will be our adjacent. So opposite and adjacent can swap around, but the hypotenuse always remains the same. So in this case, that is where we come with the three identities. Remember, trigonometry has to deal with triangles with three sides, three angles, three identities, three reciprocals. So the three identities, which is sine, cos, and tan, comes into play here. If we want to solve problems that have only one length of side and we are required to get another length of side. Or in some cases, when we were given only one angle and we are asked to calculate the size of the other angle with two given lengths, we can use SOHCAHTOA. SOHCAHTOA so means that when you are dealing with sine of an angle, then you have to get the ratio of opposite and hypotenuse. If you are dealing with the cos of an angle, it is adjacent over the hypotenuse that will give you this. If you are dealing with the tan of an angle, then it's going to be opposite over adjacent from the given triangle. Now, in this case, If we want to get our hypotenuse in this case, it's a different triangle and a different setting from the previous example. So this is going to be, if we want to do this, we have opposites and we require our hypotenuse because we want the length of AC. Then it will be opposite over, so we are going to choose opposite over hypotenuse goes with so. Please remember, these letters cannot be swapped around, else they will give a different and wrong answer. So here, opposite, so we have sine of 30 degrees is going to be opposite, which is 4 in the given triangle, over hypotenuse, which is the length of AC. So to get the length of AC, if we cross multiply, we have sine of 30, which is half, times AC equals to 4. Then if we divide both sides with the coefficient of AC, and AC will be 8 units. So this is the method we use. Remember, this method can only be used if the triangle is right angled triangle. Now, this is the approach irrespective of what is given. You just have to understand the length of side given and understand that the hypotenuse is always fixed. Now the question comes, what if the triangle is not right angled? What do we do? That brings us to solutions of triangles that we are talking about. What if it is not right angled triangle? Like for instance, if we have this. Then it means SOHCAHTOA cannot work. Pythagoras cannot work. So that is when we start looking at other theorems that we can use to solve our problems. Let's look at some of them. Now, let's say we have triangle XYZ, and this is giving us 60 degrees. Then we have 5 and we have 5. If we have problems like this, SOHCAHTOA cannot work, but we check, we can see what was given. There's an angle. There is a side and two sides given. The two sides are around the angle. We call it two sides and included angle. Whenever you have these two cases, that the two lengths given are, the angle is in the middle of them, then you have to use what we call the cosine rule. Remember this case? Two sides given with an included angle, we use cosine rule. Cosine rule says that for that, this is our little letter x. If we place it, if we go here, this is our little letter y, and this is our little letter z. So cosine rule says that for us to get the length yz, which is little letter x, we have x squared is equal to z squared plus y squared plus 2zy cos of the included angle, which is x in this case. So that is cosine rule. That is one of the conditions. Another condition that can make us use the cosine rule is when the three lengths are given. If we have three lengths given, let's say 7, 5, and 8. If we have three lengths given, we can use the cosine rule to work. We can use the cosine rule to work. No angle is given, but if we want to determine the value of any of the angles, we can also use cosine rule, and this applies. So, it is the same approach we can use here for what we have. This is our C, this is our A, sorry. So we can still use A squared equals to B squared plus C squared minus 2AB cos of A, if that is the angle in question that we are looking for. This way, we can also get the angle using the cosine rule. So the cosine rule works When we have two sides and included angle given, or when we have three sides given with no angle, then we can use cosine rule. Let's look at the next one quickly. We can also use what we call the sine rule in some cases. The sine rule is also another solution of triangle depending on the conditions given. Remember, these conditions are specific to the method. They may not work for another method. Let's look at this triangle, for example. For this triangle, I have 5 here, I have 5 here. We have 3 types of triangles: scaling, equilateral, and isosceles. If two sides are equal, it means this is an isosceles triangle. So I can go on and make sure that the base angles are equal because it is isosceles. Now it transforms to equilateral because of the equal angles. But for this, we can easily use the sine rule to calculate the value of the length yz. So, how do we go about it? Remember, for us to use sine rule, one side and 2 angles must be given, or 2 sides and 1 angle facing one of the sides must be given. Those are the 2 conditions. 1 side and 2 angles, or 2 sides and 1 angle facing one of the sides. So the rule is that if we have this, we'll have x over sine of x, will be equals to y over sine of y, which will be equals to z over sine of z. For this, we have these 3 to accommodate everything that you can only choose 2 at a time to work around. So if the triangle you have is not conforming to cosine rule, you can also switch to sine rule. Because if we have a case of this, for instance, triangle ABC, and we have like 50 here, and we have 7, and we have 6 here. This is not the included angle. And because no other angle is given, we cannot get the included angle. Hence, we cannot use cosine rule. But here we have 2 lengths of side given with an angle facing one of the lengths of the sides. Here we now employ the services of the sine rule. And we can easily go through this. 7 over sine of 50 is equals to 6 over sine of angle B, if that is the angle we want to get. We can take the necessary steps until we get even the length of the other sides using sine rule as well. There are cases also where we have to combine 1 or 2 to get our desired result. Let's quickly look at the last method. The last approach is when we are asked to figure out the area. For instance, if they ask us to find the area of triangle XYZ. Remember that the area of triangle generally that we learned in lower grades is half base times perpendicular height. Now, there must be a base and there must be a perpendicular height for this formula to work. The height must be perpendicular to this. So, let's go back to our original triangle. If we have this will be the base, which must be perpendicular to the height for this triangle for us to be able to calculate the area of the triangle using this. Even if the height wasn't given, it can also be given by the side. We can calculate using this. But in cases where we don't have any height on triangles, we can also calculate the area of the triangles using what we call the area rule. Using what we call the area rule. For the area rule, we say that it is half of the 2 sides plus their times their included angle. So if I'm working with this, it must be half of the 2 sides given plus their included angle. Please remember, for you to use area rule, you must have 2 sides and included angle. So if it's not given, you can use cosine rule or sine rule to get what you need. But for you to use area rule, it must be half or the product of the two sides times the sine of the included angle. So in triangle ABC, we can have BC sine A because A will be included, or we can have half of AC sine B. This is typical. If we have this triangle ABC, then for us to get this, the area of this triangle, remember this is our small b and this is our small c, so it's going to be half of CB sine A, included angle. If we are working on this, it's going to be half of CA, sine of the included angle. If we are working on this, it's going to be half of BA, sine of the included angle. So these are the basic solution of triangles, or how to solve problems using different methods around solve problem of triangles using different methods. So please, if you have questions, pop in questions. In our next video, we will give you examples using one of them, one after the other. We're using the SOHCAHTOA, using the pi, using the sine, the cosine, and also using the area to solve problems. Please continue to study, continue to share our videos. I'll see you in the next video to give you further examples. We'll break them down so that you can understand better. Enjoy the rest of it.